everyone. Today, we're talking about one of the trickiest bugs in computer science, the race condition. A race condition happens when a software system tries to perform two or more operations at the same time, but because they aren't synchronized correctly, they race each other to finish. The result, the winner of the race determines the output, meaning the behavior of your program becomes unpredictable and buggy.
To understand why this happens, you have to understand multithreading. Modern computers are powerful because they don't just do one thing at a time. They run multiple threads of execution simultaneously. Usually, this makes apps faster and more efficient. For example, one thread might download a file while another thread updates the user interface. They work side by side to get the job done.
Multithreading is great until those threads try to touch the same piece of data at the exact same moment. This is called shared resource. Imagine a single variable in your code, like a counter or bank balance. If thread A tries to read that variable, while thread B is trying to delete it, chaos ensues. We call the specific part of the code where these shared resources are accessed the critical section.
Let's visualize this with a real-world example. Imagine there is only one spot left to reserve. Two different users, person X and person Y, log in to buy it at the exact same second. The server has a variable called tickets available and it equals to 1. Both users click buy simultaneously. This is where the race begins.
Here is exactly where the bug happens. The computer performs a check then act sequence. Person X's thread checks the database. Are there tickets? The database says yes, one left. But before person X's thread can subtract that ticket and update the database to 0, person Y's thread also checks. Since person X hasn't finished yet, the database still tells person Y, yes, one left.
Because of that tiny gap in timing, both threads proceed to the act phase. Person X thread sells the ticket and updates the count to 0, but person Y thread also sells the ticket and updates the count. Now the system has sold 2 tickets when only one existed. We have corrupted the data and oversold the movie theater. In a banking app, this could mean withdrawing money you don't actually have.
So, how do programmers fix this? We use a tool called LOCK or mutex, which stands for the mutual exclusion. Think of this like a key to a room. Only one person or thread can have the key at a time. If a person X enters the critical section, they lock the data. Even if person Y is faster, they are forced to wait outside until person X is finished and unlock the door.
To wrap up, race conditions are dangerous because they are hard to reproduce. They depend on lucky or unlucky timing, but by identifying shared resources and using synchronization tools like locks, we ensure that our code is thread safe. Thanks for watching, and remember, in programming, it's not about who finishes first, it's about who coordinates best.